Good afternoon, everyone. Today we're going to be going over moles of compounds. My group is myself, AB, Omar, and Nuruddin. I want to quickly thank Omar and Abdurrahman Ibrahim for making this PowerPoint. Me and Nuruddin will be going over the four lessons in this PowerPoint. I'll go over 1 and 2. Nuruddin will go over 3 and 4. Please enjoy. So in this lesson, we're going to be going over, first of all, introductions to chemical formulas. Then we're going to be finding out how to find the molar mass of a compound, then converting moles to the number of particles, then converting moles to mass and mass to moles. Introduction and chemical formulas. So to quickly review, a mole is basically Avogadro's number, and if we go back and look at Avogadro's number is equivalent to 6.02 times 10 to the power of 23. The molar mass of a substance is the mass in grams of any mole of any substance, and the unit of molar mass is grams per mole. The molar mass can also be represented as the atomic mass of the element that can be found on the periodic table. So now balance chemical equations. Okay, what is a representative particle? A representative particle is any atom or molecule or formula unit or ion that can be found in a chemical equation. Now the information in the chemical formula, what the thing about the chemical formula is a balanced chemical equation tells up about the number of atoms contained in one unit of the compound and also indicates the number of moles of each atom. So by having a balanced chemical equation, by looking at the coefficients and the number of molecules that exist in the chemical reaction, we can find out the number of moles within compounds, the number of moles within elements, and even the mass of these compounds and elements. Now, just to be clear, which is something that Ms. Annie always quotes, so you never get a mistake on your chemistry exam, never forget to balance the chemical equation. Balancing the chemical equation is always going to give you the right answer. Moving on to finding the molar mass of compounds. Now this can be done easily. It's just a small extra step. First of all, counting the number of each moles of each element. Now that can be found on the periodic table because, like we said earlier, the molar mass is the same as the atomic mass that can be found on the periodic table, which is equivalent to step 2. And finally, step 3 is multiplying the molar mass by the number of moles of each element and then adding these two together. Now, on the next slide here, we have an example. So, for example, you see hydrogen has an atomic mass of basically 1. When you answer these questions, you can basically round them up. We have 1 mole of carbon and 4 moles of oxygen in this diagram right here. So the molar mass of carbon is 12, and the molar mass of hydrogen is 1. So 4 times 1 plus 12, which gives us right about 16 grams in terms of molar mass of this compound right here. Here's quick tips in solving. So first and foremost, before you think about solving, balance the chemical equation. Like we mentioned earlier, it is very, very important to balance the chemical equation before you do anything at all. Because if you work and begin solving without a balanced chemical equation, you'll get your entire answer wrong. Secondly, make sure to differentiate between single elements and formula units. This can get confusing if we have things such as the polyatomic ions that we took in previous modules, as well as you have to look at the numbers that follow the elements. So for example, if we have H2, that means there's going to be 2 molecules of H2, so it's going to have a molar mass of right about 2 and not 1. Number 3, never forget the unit grams. Labeling is very important right after you solve. And lastly, do not get confused between the grams and the atomic unit, the mass of the atomic unit.
Hello, good morning everyone. And let's begin with my topic. The first topic that I'll be covering is converting to and from the number of moles to particles. Now let's move forward. So basically what we will be doing is finding the molar mass of a compound. We're going to be using the periodic table for this. Finding the number of moles in a substance. And we're going to be using Avogadro's number to find the number of particles or formula units present in a certain molecule. Okay, now let's begin. The first problem we're faced with is the following. Aluminum chloride, or AlCl3, is used in refining petroleum and manufacturing rubber and lubricants. A sample of aluminum chloride has a mass of 35.6 grams. How many aluminum ions are present? That's A. B. How many chloride ions are present? And C. What is the mass in grams of one formula unit of aluminum chloride? Now let's begin with A. How many aluminum ions are present? Now before we begin, let's first make sure we have all the information we need. So let's refer back to the periodic table. Using the periodic table, we will get the atomic mass of chlorine and atomic mass of aluminum. Now remember that the atomic mass is the same as the molar mass, just in a different unit. The molar mass is the same in digits of the atomic mass, but the molar mass is in grams per moles. Now let's take the molar mass of chlorine multiplied by 3 and add it to the molar mass of aluminum. That way we'll find out that the molar mass of aluminum chloride is 133.2 grams per mole. Now, since the sample is 35.6 grams, let's divide 35.6 grams over 133.2 grams to find out the amount of moles that we are dealing with. When we do that, we find out that the sample consists of 0.27 moles of aluminum chloride. Now, since we know that in each in a formula unit, in 1 mole of the substance aluminum chloride, there is 1 mole of aluminum and 3 moles of chlorine. Okay, and we have 0.27 moles of the substance. Now, seeing that, we can find the amount of moles of each specific substance inside aluminum chloride. Now, since there's 1 mole of aluminum per mole of aluminum chloride, and then we can conclude that there is 0.27 moles of aluminum. And since there's 3 moles of chlorine, just multiply 0.27 times 3 and you get 0.81 moles of chlorine. Does that make sense? Okay, now let's move on. Okay, now let's start by solving A, B, and C. So first, A asks us how many aluminum ions are present. Since we know that there is 0.27 moles of aluminum in aluminum chloride, we just multiply that by Avogadro's number, and what do we end up with? 1.6254 times 10 to the power of 23 aluminum ions. Let's do the same for chlorine ions. We know that there is 0.81 moles of chlorine. Multiply that by Avogadro's number, which is 6.02 times 10 to the power of 23. We end up with 4.876 times 10 to the power of 23 chlorine ions. Now, finally, C asks us, what is the mass in grams of 1 formula unit of aluminum chloride? Now, that's simple. It just wants us to find the most, like the mass of 1 aluminum ion and 1 aluminum atom and 3 chlorine atoms or ions, present together, not as a mole, but as a single formula unit. So each of them in their most basic form, as atoms, basically. Now, to do that, we just take the molar mass of aluminum chloride, which we already got, is 133.2, divide that by Avogadro's number, and we end up with 2.21 times 10 to the power of negative 21 grams. That's a very small number, because the mass of formula unit of any substance is typically very small, since we're dealing with particles and now with entire substances. Now let's begin with converting moles to mass and moles to particles. So before we get into that, I want to present you guys with the golden triangle. Now, observe the triangle for a second. You'll see that at the top of the triangle, you have a section called mass in grams. On the bottom left, you have number of moles. On the bottom right, you have molar mass. Think of every line separating the sections as an equal sign. If you do that, you'll find that the triangle is very easy to read. Now, let's look at the mass in grams. Think of the line under the mass in grams as an equal sign, and the other two sections being the operation used. What this triangle is telling you is that the mass in grams is equal to the number of moles times the molar mass. Now let's go to the number of moles. Think of the line to the right of the number of moles as an equal sign. What is the triangle telling you? That the number of moles is equal to the mass in grams over the molar mass. Now let's go to molar mass. What is the line on the left telling you? It's telling you that the molar mass is equal to the mass in grams over the number of moles. It's a very easy triangle to use, and if you memorize it, it will help you a lot. Okay, now let's move on to the final question, the final problem. So the problem is asking you, the characteristic odor of garlic is due to allyl sulfide, which is C3H5H2S. What is the mass of 2.5 moles of allyl sulfide? Okay, now when we refer back to the periodic table, we'll see that allyl sulfide, after we use the method that I just showed you to find the molar mass of each substance, allyl sulfide has a molar mass of 114.065 grams per mole. And what is the question asking you? What is the mass of 2.5 moles of that substance? So it's really easy. After we find the molar mass by getting the atomic mass of each particle, multiplying it by the amount of the particle present, and then adding them all together, we'll get that molar mass. Now, after we get that molar mass, multiply it by the amount of moles that you want to find the mass of, which is 2.5. So 2.5 times 114.065 grams equals to 185.5 grams. And that's it. It's as simple as that.
Hello, AB here. I'm here to talk about the sources that we used in this presentation. The first source that we used was the McGohill book, the book that Miss Anne uses to teach us, and the thing that we've been using since the start of the year. The second source that we used was a website called Britannica, and the third source that we used was a website called thought.com. And hope that you understood from anything from this lesson. Thank you. Have a good day.